And when you do application, you can analyze the outcome and in addition, like you can also analyze the like part of the that's why all the switching from machine learning kind of thing for the
Nowadays they are practicing the deep learning. Yeah, then convolutional neural network. I hope everyone knows these things. Like it's a structure of it's a kind of neural network, and it's a deep learning, popular deep learning work, and apply the traditional convolution also the in medical imaging with the filtering, high pass filtering initial days, like the for edge detection, we use some kernels and apply to the original images. After that, we receive some edges. The same procedure here is used in combination with the neural network, the input image in this case, then apply the convolution and nonlinearity. This convolution nonlinearity is used for extracting the features. Like filters, we use the edge filters. Then from the edge filters, we observe the edges as the features. Similarly, there are some homogeneous intensity values, and etc. And pooling means it's reducing the size of the image. And for neural network or feed forward network, here we required a single dimension thing. So just to divide it and apply the convolution again and again. Picture extraction and classification is coming in coming in the same picture. Like we can use one single deep learning model for doing both the activities. So complex feature extraction or feature learning from the images. Images means it's not only one images, it's a bunch of data, like 1,000, 10,000 images. They capture the images and they analyze the images and they extract the features and classify it. Okay. And these are the trends. Like for 2D segmentation, the popularly used techniques are NN-UNet and UNet plus. Classification, this ResNet, DensNet, DenseNet are popular. And yes, now
so one data, especially labeled data means
do all these tasks because hundreds of data or hundreds of image, boundary detection is not possible by humans. So in that scenario, what the companies like Google or Facebook, they are trying to do, like they develop some pre-trained model. And I think this segment anything model, it's one of the popular from the Facebook. and released this segment anything model for using, like they trained a lot of the maximum number of images available in the industry or in the data set public repositories, and they trained with those data set, and they released the segment anything model for you. So that is the best first step for if you are interested for doing something in the segmentation area nowadays. And what people are doing, like that segment anything model, it's a pre-trained model, and it's trained in a large data set. The medical imaging community, they adopt that segment anything model and again train with the available medical imaging sets. And nowadays those data set or those, then they call the model is again they renamed as medsam, and this medsam is nowadays used in some they are also some people are using for another experiment, and they claim that the performance of those foundation models or the pre-trained models show outperform compared to the other. The labeled data availability is very difficult. And yeah, they recently released medsam 2 and 3, and yeah, I will show you. I will show you the this is I think, yeah, this is the medsam 2 page. It is freely available, and you check like this. Yeah, from this figure itself you notice that a lot of data they segmented now by using the medsam 2 by trained using the medical image data set instead of the normal data set. And from this video itself they mentioned like the abnormal areas very clearly by using they medsam in sam2. They generally used the sam2, that general model, but it's showing like it's abnormal, it's no abnormality, it's not it's equal to the ground truth. Ground truth is the actual boundary detected by the radiologist, and in the mid-SAM, it is performed well compared to the SAM2. And finally, they apply different segmentation for different parts of the body parts, and like global image segmentation and things. And yeah, and they released a large, sorry, sorry. Yes. And also they released a data set, a large data set, medical vision transformer data set and data list in the GitHub repository. Check the data set, pure data set, medical imaging data set in this platform also. And in addition to that, the final word is related to the foundation model. Our group is also developing some foundation model, and they developed the model related to our knee MRI images, and they released these data in the ICAIEI challenge, and some groups are doing like very good job, and they easily detect or easily classify or easily segment the femurs tibia and patella, and also the cartilage areas. And this is my work related to the artificial intelligence things. Yeah, for the bone shape segmentation of the hip area, I used the foundation model or the pre-trained model is used as the base for my training and testing of then in hip osteoarthritis condition or this kind of activity, I used a small number of data set, but the accuracy and precision and recall and F1 score showed a good performance compared to the others because of the use of the pre-trained model. And this time I'm telling another thing is, instead of telling accuracy, you always talk about precision and recall, because accuracy alone is not giving a performance. It's not a simple, it's we can say it's an accuracy of 98 percentage for a model means it's nothing. You should check as a serious AI technologist or AI developer. The one data set is it's very high compared to the other, like the diseased one and or the healthy one, it's more in numbers. Definitely it affect the accuracy. It showed like a 98 percentage accuracy, but you should check the precision and recall in addition to the accuracy of any machine learning or deep learning um, models. Okay. And finally, this is yeah, in our experiment, we added, in addition to the segmentation we use for getting a more accurate segmentation, we used human in the loop strategy also. Nowadays everyone is following, every medical field or medical researchers are following the same strategy. That means after first iteration, we provide the results to a platform, like we are using and after that again those data are used as a gold standard, and they again added to the training data set. Then second iteration, third iteration, same way the human in the loop strategy, it's also very effective nowadays, and the radiology people are now using these technologies in addition to the foundations model. These are all the deep learning development related to the medical imaging. And finally, one sample, recently I saw one paper, they mentioned that, or they released that it's a segmenting whole body MRI and CT. They captured or they acquired and they collected from the public repositories and their own in-house data set of both the MRI and CT, and they automatically segmented around 40 classes of the digestive system. That means they acquire a lot of data and they use simple unit model. They are not going to, they are only doing the unit, they are doing the unit and pre-trained model. They did a good job, like they classify or segment the whole body MRI. But still some challenges they are facing in the brain images. And yeah, they show the corresponding results, like here the dice score, it's one of the what I can say, the metric, the performance metric. And here the adrenal left and the pancreas, esophagus, colon. So here their machines or their cells are facing around 70%. So still challenges are there. Segment, they done very good job, like they completed or finished the segmentation of the 40 organs or 40 different tissues in human body. And some part is showing very high performance, like the dice score is more than 90 percentage. However, still challenges, and we need like more algorithms or more kind of testing we required, and for fulfilling the high accurate, high precise, highly precise segmentation results. And these are the some of the available public data set for like researchers like you should start with a like a Kaggle. It's one option, and then is available. So much total segmental MRI data set is available. Brain tumor segmentation challenge, BRATS, it's another challenge. So first you try to download all these data and try with the present available um, methodologies, and then you try to improve further by using the by using different techniques or modifying the model, etc. Yeah, for the time constraint, I just to conclude from this point, what I am trying to say is it's deep learning is growing, medical image is growing, but it is never going to replace the radiologist. It's definitely it helpful for the radiologist for doing the activities. So you should focus in that area, like trying to increase the then it will be helpful for the clinician community for doing a better diagnosis and better treatment plan. And AI algorithms, especially the deep learning, are increasingly capable of analyzing the complex medical images. It definitely it gives the idea of diagnosing, and they are the clinicians get the chance to how they are going with the personalized treatment. And obviously deep learning is not a longer a futuristic concept. It is away, it is presently there and deployed somewhere, some hospitals also. And yeah, our focus must shift from isolated algorithm development to robust validation, integration with the clinical explainable most of the time I saw that the medical imaging scientist or the computer scientist, what they are doing, they are just approach the clinicians or doctor for getting the images. It is not the correct way. You first identify the problem and you study thoroughly the biology of the images, or thoroughly biology of the tissue and the abnormality, and then you go and discuss with the doctor, and if they are interested, then they provide the data and all things, because data is nothing. Data is available, publicly available, and its large data sets are available for your practice. So you first start practicing the available data set, and you develop some model or generate some model. And in Indian perspective, we require like first you familiarize the model by using public repositories, then start communicating with the doctors or clinicians or radiologists, and then collaborate with them and acquire the data of patients, because definitely there is ethical problems or ethical issues are available. So definitely overcome those and take the local data and add to your the pre-trained model. We can say the pre-trained model, hence the quality definitely helpful for the patients. It will definitely helpful for our society. So finally, the word is the future of